Welcome back to today's Explainer. We're doing something a little different today, and honestly, pretty mind-blowing. We're picking a random file from a dense mathematical codebase, specifically a Lean4 formal proof called polysemi as multiple waves.lean, and we are going deep. We're looking at this incredible intersection of human language, pure mathematics, and quantum physics. The way this math maps out the hidden architecture of the words we use every single day is, well, it's absolutely fascinating.
Okay, let's dive into this. When you read a sentence, your brain usually processes words as static units of meaning, right? Kind of like tiny, solid bricks of information. But the mathematics in this Lean4 source file proposes a massive, radical shift. What if words aren't bricks at all? What if, on a cognitive and mathematical level, they behave exactly like quantum standing waves? Like, what if the sentence you're processing right this second is actually a complex physics equation resolving itself in real time inside your mind? To understand how this works, we first have to look at the core problem of human language.
And that core problem is called polysemi. It's basically the linguistic phenomenon where a single word carries multiple, completely distinct meanings. You know, in computer science or formal logic, ambiguity is a bug, right? It breaks code, it confuses algorithms, but in human language, it's everywhere. It's actually a feature. Our words are heavily overloaded. They carry different definitions depending entirely on the situation. And this mathematical proof we're unpacking today was written specifically to solve how our brains manage all this ambiguity without, constantly crashing.
And this brilliantly illustrates the point. Think about the word bank. If I say bank account, your brain instantly retrieves the concept of a financial institution, vaults, money, the whole shebang. But if I say riverbank, you instantly picture the muddy edge of a flowing stream. You don't have to pause. You don't consciously weigh the options and discard the wrong one. Your mind just effortlessly snaps to the correct meaning. How? Well, standard linguistics might say, oh, it's just context rules. But our Lean4 source code, it models this entirely differently.
Section 1. The Physics of Meaning.
So the mathematical proofs we're analyzing here don't treat grammar as abstract rules or simple lookup tables. Instead, they model these dual meanings as precise interacting physics. They literally use the mathematics of wave mechanics, amplitudes, frequencies, interference, to map out semantic space. According to the source file, before the context of a sentence even arrives, a word doesn't have zero meanings and it doesn't just have one. Meanings exist as stable standing waves in your semantic space. So when you hear the isolated word bank, both the finance meaning and the river meaning exist simultaneously. They're vibrating frequencies in your mind, held in a state of superposition. They are mathematically active standing waves, just waiting for a second wave to interact with.
Section 2. Metaphor as constructive interference.
Now, what's really interesting about this slide is if words are waves, what happens when two different waves crash into each other? Well, the code defines a metaphor literally as constructive interference. In physics, when two waves peak at the exact same frequency, their amplitudes add together, right? They make a larger wave. In semantics, a metaphor forms when the frequency of a source domain and a target domain overlap constructively. They share a harmonic frequency. So when you say something like time is a thief, the semantic wave of time and the wave of thief overlap at the shared frequency of loss. And boom, that creates a brand new amplified meaning right at their intersection.
Section 3. Ambiguity as destructive lock.
So, the crucial point is that waves don't always add together perfectly. Sometimes they clash. Imagine reading a really confusing sentence where two meanings are just fighting for dominance. Neither wave can reinforce the other, but neither is canceled out either. The code formally defines this as an ambiguous context where incompatible meanings refuse to collapse. Actually, the source code literally calculates a tension value right here. That subjective feeling you get, that mental friction when you're forced to reread a confusing sentence, that is mapped in the code as two semantic waves locked in destructive interference. They are mathematically fighting each other in your head.
Section 4. Literal versus metaphorical frequency.
Why does reading a dry instruction manual feel so much easier but so much less impactful than reading a complex poem? While the Lean4 file models this difference not as a matter of vocabulary, but as a matter of mathematical frequency. The proof assigns literal meanings a low frequency value, specifically an integer less than or equal to 10. Literal meanings are your direct, obvious baselines. They don't require much context, they just roll right in like long, slow ocean swells. Metaphorical meanings, on the other hand, are high frequency. They're coded as greater than 10. You have to actively work to process those rapid, complex waves, which is exactly why poetry makes your brain sweat a little bit more than basic instructions. The math literally proves that metaphors require a higher context threshold to successfully interfere.
And that brings us to a really bold claim straight from the source code. Compositionality equals superposition. Phrase meaning equals sum of parts. In quantum mechanics, the principle of superposition states that a physical system exists partly in all its particular theoretically possible states simultaneously. The code argues that word embeddings mathematically add together in the exact same way. A phrase isn't just a simple list of words. It is the literal linear superposition of component semantic waves, all added together into a single complex waveform.
Let's move to Section 5 and see how this all builds up, the collapse to one meaning.
So how does our brain actually know which version of a word to use? We started with the problem of polysemy, and we now have the complete mathematical model to predict your real-time reading experience. Let's walk through it. Step 1. The word bank arrives, generating multiple standing waves of meaning. Step 2. The context word account arrives, acting as a second wave with its own specific frequency. Step 3. The finance meaning of bank shares a frequency with account, so they phase lock. Constructive interference amplifies that finance meaning. Step 4. The river meaning of bank is entirely out of phase with account, so it undergoes destructive interference. It's mathematically canceled out. And finally, Step 5. You, the reader, experience only one single, clear meaning. The waveform has officially collapsed.
Which leaves us with this final, incredibly profound question to ponder. What we looked at today wasn't just a clever analogy. This was a formal, rigorously verified mathematical proof in Lean 4. If the exact same equations that govern quantum wave mechanics and constructive interference can perfectly map how human beings resolve semantic ambiguity, is the language we speak actually just physics vibrating in our minds? Are semantics and quantum mechanics fundamentally the exact same thing, just operating at different scales of reality? Take that thought with you today. Thank you so much for exploring this deeply fascinating topic with me, and keep your curiosity alive until next time.